Hello everyone. So today we are going to discuss the Codeforces round 1025, problem B, Slice to Survive. Now, duelists Mouf and Fouad enter the arena, which is n by m grid. Now, let's call this guy M and let's call this guy F. F's monster starts at cell AB, where rows are numbered 1 to n and columns 1 to m. So that's why we have an n by m grid. M and F will keep dueling until the grid consists of only one cell. And what are the rules? M first cuts the grid along a row or column line into two parts, discarding the part without Fuad's monster. Note that grid must have at least two cells, otherwise the game has already ended. So basically what it can do is it can make a cut. And the cut obviously divides the grid into two halves, right? The halves in which F is not present, we discard it off. And we are left with this half. This cut can be made row wise, or it can be made column wise. So for example, this is a column wise cut. It cuts it along the column. We can also have a cut along the row like this. Now, after that, in the same turn, F moves his monster to any cell. Okay, now F, like for example, he is here, right? He can move to any cell he wants. He can move his monster to any cell he wants, any cell in the remaining area. M wants to minimize the number of turns while F wants to maximize them. How many turns will this epic duel last if both play optimally? So we have to tell how long will it last? What is the total number of moves required over here? And this is my input format, which says that each test consists of multiple test cases, and every line will consist of 4 integer nm. So remember, it's a n by m grid. And AB, what does AB represent? AB represents the starting row of the monster and the starting column of the monster. So basically, initially the monster is at A comma B. Let's try to solve the problem when it's a 1D grid. Okay, let's say the grid is only 1D. So let's say it's only a row. Okay, now let's say the monster initially is present at this side. So what kind of cut will you make? Obviously, we will make this cut, right? And when we make this cut, what are we left with? We're just left with this, and the game is over. So how many turns do we require from here to here? The number of turns required is only one, right? Now let's change the initial position. Let's change the initial position of the monster. So let's say the monster was not initially here, rather the monster was initially over here. Okay. Now how should I make the cut? I can make the cut like this, or I can make a cut like this. Okay. So since my task is to isolate the monster until there is only one cell left, if you see right over here, cutting it like that will leave the monster with 1, 2, 3, 4 spaces, right? And if I cut it like this, the monster is left with 1, 2, and 3 spaces. So this cut looks more optimal to me. So let's cut it like this. So if I make this cut, we're left with this, right? Now in this same attempt, this guy has the opportunity to run away, right? In one turn, what happens? First cuts the grid, and what happens after that? In the same turn, F, like Fouad, moves his monster to any cell. So this monster has an opportunity to move anywhere. Now, if you think about it, should he move? Obviously, he should move, because in the next turn, my cut is going to be like this, and the number of turns will be over, right? But his aim is to maximize the number of turns. So what will he do? He will shift it here. He will go here, right? So in the same move, this happens, and this guy moves to this cell, right? So this is my first turn. And the second turn, what will I do? But naturally, we have to make a cut like this. Both the cuts are same. You can also make a cut like this, right? So they are identical kind of cuts. So now this is the scenario. Now no matter if the monster moves to this position or this position, it's identical, because in the next move, the game is going to be over, right? The next move, we're going to make a cut like this, and the monster is left with only one space. So how many turns are there? How many turns are in there in total? So there are a total of 3 turns, right? Think about it. Like, the monster will always try to move in a space that is actually in the middle, like, because he has to maximize his space for himself, right? Because if he moves somewhere that is not the middle, okay, so let's say we have 5 spaces, or let's say we have spaces like this, total of 9 spaces, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, monster F can place his monster anywhere in the grid, right? So the argument over here is that he should place the monster at the center over here. Why? So that the number of turns could be maximized. You should place it in the center, because let's say if he does not place it in the center, okay, instead of center, let's say he plays it here, okay. So how is my cut gonna be? My cut is going to be like this, obviously, right? So now how many spaces does he have? He has only 4 spaces. But if you place it in the center, my cut could be like this, right? And he has how many spaces? 1, 2, 3, 4, 5 spaces, right? Or if I put a cut like this, he still has 5 spaces, right? 1, 2, 3, 4, 5. Okay, but if he places somewhere away from the center, if he places somewhere away from the center, let's say he places it here, Then I will make a cut over here. And now how many spaces does he have? He has only 3 spaces left. So what is the optimal strategy for Fouad will be? It will be always place it in the center, right? And what will be the optimal strategy for Mouf? Make a cut such that F has least space to travel. That will be the optimal strategy. If you think about it, we have been given an initial position a comma b, right? Let's bring this problem to a 2D grid now. But before bringing it to 2D grid, let's first understand what happens in a 1D grid. Okay. Every time, what will happen? F will try to place himself at the center, and M will make a cut at the center. So every time, don't you think the size of the grid, if it's a 1D grid, will reduce by half? Let's try and understand this for 1D grid using an example. So let's take the same grid over here. Okay. So over here, let's say this is the initial position. So this grid will obviously, the number of rows is 1, the number of columns is 9, and the initial position of the robot of the monster is at the first row, and the column of this robot is gonna be how much? 1, 2, 3, 4, and 5. The turn consists of 2 parts, right? Each turn consists of 2 parts. The first part is the cut, and the second part is the move, right? The monster can move then. So the first part is cut. Now, if I make a cut and the monster has nowhere to move, then in only one turn the game is over, right? So how should I cut it? So I should have cut it like this, or I should cut it like this, right? So let's make a cut. I cut it like this. So the new scene looks kind of like this. Okay. Now move, right? Now he should try and move. He should try and move. So where will he move? Well, he should optimally move in the center, right? Because he does not want to get isolated. So let's move him. So he will go, okay, I'll place my monster over here. Okay. Now again, so one turn is completed, right? So one turn is completed. Now this is one turn. Let's talk about the second turn. Again, make a cut, right? So I'll make a cut like this. Okay. What will be left? So this will be left, right? Now again, monster has to move somewhere. So he will move like this, right? He will move again to the center, right? So another turn is completed, right? Cut and move. So another turn is completed. So there are 2 turns completed. Now again, we have to make a cut. So we'll make a cut like this. So what happens now? So we're left with only 2 cells. Now again, the monster has to move. Moving for the monster is useless. Even if he does not move, he's gonna be packed in the next move. So let's say he moved. Okay. So another move completed. And now what happens? I'll make one cut and we are left with only 1 cell, right? I'll make a cut like this and we'll be left with only 1 cell, right? So there's a total of 1, 2, 3, 4 moves, right? A total of 4 moves, isn't it? And remember how many cells were there initially? There were a total of 9 cells initially. So what did we do in the very first move? In the very first move, we made a cut very adjacent to the monster. We made a cut like this, right? In the very first move, we made a cut like this, or we could have made a cut like that, right? So our grid basically reduced, right? Now the number of rows is 1, but the number of column is how many? The number of column is 5, right? The number of column is 5. Basically, the number of columns that we are left with, right, is 5. Now after this, the monster will basically try and move in the center. So if you think about it, what's happening at every step is that the number of cells is getting reduced by half, approximately half, if you think about it, like, because we are always making the cut in the center. And if you think carefully, the number of cells at every step is basically this, right? We'll have to find the seal value, because let's say if the number of cells were 4 and my bot was here, so we'll make a cut like this, right? We'll make a cut like this. So how many are you left with? You're left with 2, right? So at every step or at every turn, what's happening for a particular row or for a particular column, because if it's a grid, the cut can also be made like this, right? So at every turn, what is happening? The cells are basically becoming equals to seal of cells upon 2, right? Okay. Now let's take an example with the grid. Let's say the monster is over here. So in the very first step, I can make a cut like this, right? Or I can make a cut like this. Or I can also make a cut like this, right? Because if I make a cut like, let's say this, the monster is left with how many rows? 1, 2, 3 rows, right? And if I make a cut like this, the monster is left with 1, 2, and 3 rows. So it's the same, right? But let's say the monster was here. Let's say the monster was over here. So I can make a cut like this or I can make a cut like this. But obviously this cut is more important because here the monster is left with 2 rows. If I make a cut like this, the monster is left with 1, 2, 3, 4 rows, right? So what basically over here is happening? So initially my monster is at A, right? And the total number of rows is n. Okay. So when I make a cut, I have to ensure that the monster is left with the minimum number of rows. So if I make a, let's say, if I make a cut like this, monster is left with how many rows? 2 rows. Basically, it is the value of A over here, right? Isn't it? And if I make a cut like this, the monster is left with how many rows? 1, 2, 3, 4 rows over here. So that is actually equals to how much? It is actually equals to n minus A plus 1. Okay, if you think about it. So let's say the monster was over here. Let's say the monster was over here. So what is the value of A? The value of A is 4. And what is, okay, what is the value of A? It's 4. So should I make a cut like this or should I make a cut like this? But naturally we'll say you should make a cut like this, right? So if I make a cut like this, how many rows are we left with? We're left with 2 rows, right? So it is actually equals to how much? It is 5 minus 4 plus 1, right? N minus A plus 1. So we will be left with this much. If I make a row wise cut, we have to take the minimum of these two, right? Now, similarly, I can make a cut like this or I can make a cut like this, right? So in the beginning, I will either make a row wise cut or a column wise cut. Okay, so I'm considering the column wise cut as well. So initially, how many columns are there? Oh, there are also 5 columns. So over here, if I make a cut like this, I'm left with 3 columns. If I make a cut like this, I'm left with 3 columns, right? But let's say it was over here. Okay, so if I make a cut like this, I'm left with 2 columns. And if I make a cut like this, I'm left with 1, 2, 3, 4 columns. So well, it depends, right? It depends where it's positioned. So the number of columns that I'm left with after making cut would be, like, you can symmetrically derive the formula. It will be this, right? After the initial cut, okay. So if the row, if the cut is row wise, we will be left with this much of rows, right? And if the left is column wise, and if the cut is column wise, we will be left with this much of columns, right? Now after that, what will happen in the leftover rows or column? The monster will try to move in the middle. So the question is, will it try to move in the middle of the row, or will it try to move in the middle of the column, or will it try to do the both of them at the same time? But naturally, it will try to secure its middle position row wise as well as column wise. Okay. So let's reposition our monster. So let's say our monster is over here. I can make a row wise cut or I can make a column wise cut. Let's say if I make a row wise cut, okay, because it looks symmetrical. Let's say I make a cut like this. I'm left with this portion, right? So now this guy over here will try to move where? It will try to move in the center, row wise as well as column wise. Well, if you see column wise, it's already in the center, right? It's already in the center. It will try to move center the row wise, so it will move one ahead. It will move here. Let's try to make a column wise cut like this now. Okay. So now it is here, right? So now it will try to move in the center. Obviously, this is the center, isn't it? Now again, we have to make a cut. So let's make a column wise cut again. So it's left with this much of space now. So where will it move? Well, it will try to move somewhere. Let's say it moves here because that's the center. It is already at the center, right? So now again, let's make the column wise cut. So now it's packed, right? It can only move in the row. Will it move? It should not move, right? It should not move because if he moves, he's done, right? He should stay here. Now we'll make a row wise cut like this. Now he has to move, right? Now again, should he move? Should he move? Even if he moves, it doesn't matter. Let's say he moves, and now again we make a cut. So now the game is over because he can't move any further, right? So how many operations are required? 1, 2, 3, 4, 5, 6. 6 operations are needed, right? 6 operations are needed. And where was my initial position? Our dot was initially at this position, right? So what was the value of A? A was 3 and B was 3, right? N was 5 and M was 5. So a total of 6 moves was required in the previous example. Now let's see how will we approach this problem. Now we will make an initial cut, right? We will make an initial cut, and the initial cut would be row wise or it would be column wise. Okay. Now after making the initial cut, we are basically giving the monster the space to select any row or column he wants, right? So he'll always position himself at the center, right? So after the initial cut, monster will always position itself at the center, right? So if you make a column wise cut, okay, if you make a column wise cut, so you're left with how many columns? You're left with this much of columns. And you're left with how much of rows? You're left with, well, n number of rows initially. And now your column and rows will go down by 2. And every step you make a cut, you will either make a cut row wise or column wise. But what will happen? As the monster keeps on moving, the number of cells along the row or along the column will be halved, okay, because it always takes the center. So at every step, what will happen? Column will become column over 2 and row will become row over 2, right? And remember, we have to take the seal value of it, right? I've shown it by taking the 1D example, okay? So this will happen every time, right? Will happen in every turn. So either this will happen in every turn or this will happen in every turn. And at the end, basically, we have to add these two up. So the question is, how many times can we do C is equals to C over 2? You can always say, you can write a while loop for that, or you can simply use the maths. Like it will be equals to log base 2, right, of the total number of columns, right? And this will be equals to log base 2 over the total number of rows, isn't it? That will be the, and final answer would be this plus this, right? Okay, so let's summarize what we will be doing. First of all, we're gonna make a cut. That cut could be a row wise cut or a column wise cut. If the initial cut is row wise, so the number of rows that we will be left with will be minimum of, we've discussed this. And if the initial cut is column wise, we will be left with how many columns? We will be left with minimum of b comma m minus b plus 1 columns, right? If the initial cut is column wise, this is the number of columns that we have, and the number of rows that we'll be having is gonna be n, right? After making the initial cut, monster has a chance to place itself at the center, and after that, the number of rows in the column will be halved every time. It will decrease by a factor of 2 every time. So to calculate that how many times it happens, we can make use of the logarithms, right? So basically, we can do this. We can take log base 2 this, and we can take a log base 2 of this, and we can add them up, right? Remember, when you make this operation, right, when you make this cut, that is also one operation, right? That cut is an operation, so don't forget to add one more, okay? So that is my answer. That's my answer. So let's say we'll call this x1, okay, and let's say we call this x2. So our answer is going to be 1 plus x1 plus x2, right? And remember, here the value that we will be taking will be seal value, okay? It will not be floor value. But what if the initial cut is row wise? Well, if the initial cut is row wise, okay, so we will be having m columns, right? We will be having m columns. Now again, what we will have to do, we have to take log base 2 of this, because columns is going to be halved every time, and we're going to have to take log base 2 of this. And finally, you need to add 1, because this is an operation while you make a cut, okay? So you can call this like x3, and you can call this x4. So here the answer would be x3 plus x4 plus 1, something like this, right? Well, you can output the minimum of these two values, right? The minimum of these two values is going to be our answer, okay? So let's see the code now and understand it. So this is the C++ code. We first of all start by taking the number of rows and the number of columns and the initial position of the monster. And I defined these variables so that the code looks clear. So first of all, we will take the number of times it takes to cut off the rows by half every time. So it will be x1 operations, and x2 would be the number of times it is required to cut off the columns, okay? Now x3, so remember, if you made an initial row wise cut, so the number of rows that you will be having will be this, right? Minimum of a comma n minus a plus 1, right? So x3, we are storing that in x3, the number of times that it will require to cut down that. And similarly, if you make an initial column wise cut, we'll be having this much of columns, and the number of operations required to cut off that column by half every time would be this, basically log base 2. Either in the very first operation, I make a column wise cut, so this is plus 1 over here, and the number of columns that I will be left with will be this, and the number of operations required to cut off all this column will be x4, okay, and the number of rows will be n, so the number of operations to cut off those rows will be x1. So the answer could be x1 plus x4, or I make a row wise cut initially. Now if I make a row wise cut initially, the number of rows that we will have is this, and the number of times it requires to cut off those rows by making them half every time is going to be x3, because we are doing log base 2. will be having m columns, and the number of times it requires to cut off those m columns by halving every time is going to be x2. So it could be x2 plus x3 also, right? So we will take the minimum of the two and this plus one operation, which we are doing the initial cut. Okay, this is my initial cut that we are doing. That is going to be my answer. So that's it. Hope it helps.